Hey, it's Ross from rosslukeman.com. Today I want to talk to you about how to add shore power to an existing power system in a van or RV. Let's say that you start out with solar power. You've got a couple of solar panels up on the roof. They're charging your battery bank. That's connected to an inverter, which is powering up your appliances. The easiest way to add shore power into this existing system would be to add a battery charger. So we would put that here, we'd plug it into the power grid, connect it to our battery bank. It's going to charge up the battery bank, and it's also going to indirectly power the inverter and power those appliances. The limitation with this, even though it's pretty easy to set up, this particular charger maxes out at 400 watts. And this is actually a larger unit. Some of them top out about 200 watts. So as long as your appliances in your van or RV don't take more than 400 watts in this case, the batteries will charge up eventually, and you'll also be able to run those appliances. The limitation happens when you turn on, let's say, a 1500 watt stove. On this end, this is going to try to supply that power. It's going to max out at 400 watts, and the additional power is actually going to come out of your battery bank, which is going to deplete as it sends that extra power to your inverter to power that stove. So even though we're plugged into the power grid, we've got our battery charger running, the batteries themselves can actually run down if you have a large appliance going, or maybe you have a couple of large appliances going at the same time. You're making breakfast. In that scenario, the batteries would deplete, and then when you turn those appliances off, the charger is going to play catch up and it's going to bring your batteries back up. So it's a little bit inefficient. We're wearing out our equipment. You can see that we are starting at 120 volts here in North America. We're stepping that down to 12 volts to charge the battery, and then we're boosting it back up to 120 volts to run those appliances. So we're going up and down with the power. The power that comes in on this end doesn't all make it to this cord to go out to your appliances. So we're wearing out our equipment. It's inefficient, and there is a better way to do this. So the better way would just be to run our appliances directly off the power grid. So we plug in this end and we run that in to our appliances, but we kind of have a new problem here in that the inverter still needs to work. When we unplug our vehicle and drive off, we need to be able to run off the inverter and the battery bank, but when we plug in, we need to be able to run off of this cord. And so how do you send two cords to run the same appliances? The way we're going to do that is we're going to add a transfer switch. So the transfer switch can actually accommodate two sources. So it'll take the wire from the inverter, and it'll also take the wire from the power grid, and it will send out one wire that goes and powers up your breaker panel to run your appliances. So this is also called a grid dominant transfer switch. So when the power grid is available, it's going to sense that, and it's going to switch over internally and pull power from the power grid and send it out to your appliances. When you unplug your vehicle, this line is going to go dead. It's going to sense that, and it's going to switch back over to the inverter, pull power from the inverter to send power out through that very same line to power your appliances. So it's automated. As soon as you plug in, it switches over. As soon as you unplug, it switches back. And it gives you kind of a worry-free way to basically automate what's going on here and run your appliances directly off the power grid. We can also loop back and tie our charger in, and we can make sure the charger only runs when you're tied into the power grid. So when this powers up, it'll power up your charger. When this goes dead, the charger will go dead. You don't really want to have your charger tied in with your inverter because that would create kind of a loop, right? Your charger charges your battery, powers your inverter would power your charger. So to create a loop, we don't want to mess with that. So the charger is only tied in with this line. I'm going to show you how to do that as well. What we're going to do is we're going to throw all of this into a power system, and I'm going to show you how to wire it. Before we do that though, if you're interested in your overall power system, not only shore power, but also solar power and alternator power, I have a resource that you may be interested in called the Ultimate Van Power Cheat Sheet. It's got a discussion of those three major charging sources, solar, shore, and alternator power. And it talks about how they all have strengths, but they also have weaknesses. But when you bring them together in a holistic power strategy, they're going to make sure you have a good charge source no matter where you find yourself on the road. So you don't have to worry about running out of power out there, and you can just enjoy your travels. So there's the discussion of those three charging sources. There's also a discussion of different battery chemistries and the strengths and weaknesses of those. And that is going to help you narrow in on which battery type is going to be right for your project. And then lastly, there is a really cool conceptual diagram that's going to show essentially your whole power system on one page. It's going to show the three charging sources at the top, solar, shore, and alternator power. And it's going to show the connections through the system where those three charging sources can come together, play nice together, charge your batteries, and get distributed to your end devices such as your microwave and your phone charger. What are all those connections in there from the, say, your solar panel on the roof all the way to your phone charger? How does that power flow through the system? So it's a really interesting diagram that I think you'll find useful. If you want your own copy of the Ultimate Van Power Cheat Sheet, all you have to do is click that link below or go to rosslukman.com/vanpower. So with that, let's throw these components into a system and we'll look at how they're wired. All right, so I've got all the components mounted on a board here, and I haven't wired everything because I wanted to bring you in kind of midway and show you what I'm going to do before I completely wire it. So just to go through the components, we have our chargers here. So we have a solar charger. We have the charger I showed you a minute ago that is going to plug into the power grid. So this is our charger area. These are both connected to positive and negative here at the system, positive and negative, and that's going to transfer that power into our battery. And then next up we have, let's jump over here, we've got our transfer switch. I'm going to show you what's going on inside there in just a second. We do have a diagram that we're going to follow there on the inside of the lid, so that's really helpful. Below the transfer switch we have our inverter, and it's set up with a cord to come right into the transfer switch. I've just got a plug here with a 14 gauge cable. The 14 gauge will carry enough current for this small inverter, but your current for the larger inverters, you may want to use a larger cable. For example, on the 30 amp shore power service here, we're using a 10 gauge cable. And I do have an extra breaker. So it should be noted when you plug into the power grid, that receptacle is going to have a breaker, but for extra safety, to have our own breaker to make sure that it's in good working order, oftentimes I'll run that incoming line through a 30 amp breaker, again with the 10 gauge cable, and then that line is going to come up and tie into our transfer switch. So these are our two main power sources there. We're going to bring them in side by side and tie them into the transfer switch. And then we could bring in the plug for the charger here. We could clip the plug off and hardwire it right into the transfer switch. But what I'm going to do is make one extra stop. I want to have a cutoff switch for the charger, and I've got this special, let me set this cord down. I've got a special pilot light switch, and this doesn't make a whole lot of sense as I currently have it set up, but in your actual van or RV, you may want to switch somewhere where you can see it because your electrical equipment will be down in some compartment. You're not going to be able to see all of this. This particular charger has a Bluetooth connection with an app and all that, but it's nice to just see the pilot light come on when the charger is on. And then if for some reason you want to plug into the power grid and run your appliances, but you don't want to charge your batteries, you can just hit this switch and kill the charger. Even if the charger is down in your electrical compartment, you can have this in a convenient location. So we're going to wire into that, and then we are going to put a receptacle above it, and we're going to actually plug into this receptacle. So we'll come in with this wire. This wire here will go into the transfer switch. It'll bring power over to here, and we'll run through the switch, and then after that go into the receptacle. So the wiring of that is a little bit beyond the scope of this video, but I just wanted to show you what I'm going to do. And that'll allow us to break the line. Even if we're plugged into the power grid, we can break the line so the charger turns off if we don't want to charge our batteries. So at this point, what we can do is zoom in on the transfer switch, and let's talk a little bit more about the wires inside there and how we need to wire it up. To start out, I wanted to mention that we're using the GoPower TS-30 transfer switch. This is a 30 amp model. 30 amps multiplied by 120 volts for the power grid here in North America is going to give us 3,600 watts of power to charge our batteries and run our appliances. And that is typically plenty for the camper vans that I build. They do make 50 amp transfer switches, but 30 amp is typically all I need, and I've used this model a couple of times. Now, as far as the internals of the transfer switch, we've got a couple things going on here. Basically, these wires at the top are your output to your breaker panel, and these wires at the bottom are your default power source. So at this time, power would run from these cords through the switch and out the top through these. And then your middle pair are actually kind of your dynamic source. So this could be a generator that turns on, or this could be the power grid that turns on. And there are kind of multiple scenarios shown in the manual. What we're going to do is we're going to put the inverter on this bottom pair. So that's going to be kind of our default source. And then we're going to put the power grid on the middle pair. So when the power grid is available and it energizes this middle pair, the switch is going to detect that. There's a little relay board here, and after about 20 to 30 seconds, it's going to quit drawing power from this pair, and it's going to draw power from this pair, and it's going to send it out the top. Now, the reason there is a delay is this can also be used with generators. So with that generator scenario, you would have the power grid coming in the bottom, your generator would come in this middle pair, and it's going to energize this line, but instead of immediately drawing power from the generator and sending it out to your appliances, it's going to give the generator 20 to 30 seconds to warm up and get going before it puts it under load. So there is a little relay board in here. Let's go ahead and pull that out. So this relay board creates the 20 to 30 second delay, and there are a couple of pins there on the board. If you put a 2-pin jumper on that, it will eliminate that delay. And if we look at the instructions, there is a little section on that. There's the board, there's the 2-pin jumper, and there are the 2 pins. So we're going to go ahead and leave the delay, but if you want to eliminate the 20 to 30 second delay, it is possible if you read the instructions. And I'm just going to point out there are a few scenarios. I know you can't see this very well. I'm not going to try to read it to you, but we have configurations A and B there, and then we're going to do configuration C between an inverter and an alternating source. And so I just want to point out that the diagram on the lid, it shows a generator. So this kind of explains, this shows how it works with the delay and all of that, but you don't have to set it up like this. There are multiple ways to set it up shown in the manual. So we're going to go with configuration C, as I said, and to repeat, that is going to be, let me go ahead and put this little bracket back in. Hide our circuit board again. Okay, got it. So inverter is going to come in here, and by default it's going to feed our breaker panel, and the power grid is going to come into this middle pair, and when it's available it's going to activate everything. After a 30-second delay, it's going to pull power from the power grid and send that to our panel, and quit taking power from the inverter. So to take that one step further, if our power grid wires are going to come into this middle pair, that is where we need to send power over to our charger. So the power grid is going to come in and feed that pair, and then our charger wire is going to come in. This is actually a 3-conductor cable, so there's a black, white, and green inside this cable as well. But what we're going to do is, you can see these little 2-way connectors here, the WAGO 221 connector. I've got some 3-way connectors, and we're going to replace these 2 ways with some 3-way connectors for these 2 wires. That'll give us an extra slot to tie in the charger hot and neutral and go ahead and siphon off power at that point. So the power grid feeds that pair. We're going to come in and siphon off power at that juncture for the charger, and then the power grid power is going to go through the switch and onto the breaker panel. So we're basically going to bring in the power grid and split it, send it up to the breaker panel, and send it over to our charger at these connectors. So hope that all made sense. We got one more thing I need to show you. The ground bar over here is going to tie in all of the ground cables from all of our conductors. So any of these green wires from the wires coming in at the top or bottom, all the greens are going to tie into this ground bar. And then there's actually a hole in the side there where we can connect a chassis ground cable and ground the entire thing to the chassis of the vehicle. So that is the gist of how the transfer switch works. At this point, I'm going to go ahead and wire up our system and we'll talk about it. I've got everything wired up. Let's go ahead and go through the system and talk about each component. The battery charger, you can see I have the cord routed over here and plugged into our outlet, which is powered by our pilot light switch. And that is just routed over and ties into our power grid wire there. You can see our inverter coming in there, our power grid cable, and then a fourth cable was added as our output cable. And this is the one that would typically go to your breaker panel. So that would be in an AC, DC distribution panel such as this Waveco, this WFCO. I'll put the model number below. Now, I typically use the PD5000 nowadays. It's a little bit smaller, but I've been using that quite a bit lately. But either one of those, that would be your breaker panel. This would go in, power up all your breakers, and then your branch lines would come into that. But for our demonstration, we'll go ahead and use our light just to indicate what's going on with the transfer switch. And on our solar charger, you can see I've got the solar panel cables that would come in. I don't have a solar panel connected, but I just kind of wanted to complete the wiring. And those chargers are both connected to our battery. I've turned on our battery switch. Lastly, you can see the chassis ground cable that would go from the transfer switch and connect to the chassis. At this point, let's go ahead and fire up our inverter. And this is the default power source. So this will go straight through the switch, no delay, and power up our light. So as soon as it turns on, the light turns on. And we are drawing power out of our battery to the inverter through the switch and to our light. So at this point, let's say we get to the campground and we plug the vehicle into the power grid. I'm going to simulate that by turning on this breaker. I clocked this transfer switch at 23 seconds. So 23 seconds after the grid power comes in, it'll switch away from the inverter and send power through from the grid to our light. Now the charger turns on immediately. You can see our pilot light is on and the charger has cranked up and begun putting power into the battery. You heard the click there. So now the charger and the light are both running off of the power grid. And one last thing I wanted to show is we've got a BMV 712 battery monitor shunt here. So this is the shunt. This is the little screen that puts out a Bluetooth signal. And what I'm going to do is get my phone here. I've got the Victron Connect app and it's connected to the battery monitor. And we're just going to look at the numbers. So you can see the number is positive. The number of watts is positive going into the battery because we're connected to the power grid. And typically, I will say, if you get to the campground and you're going to be there a week, go ahead and turn off your inverter. So you can see the inverter is off and our light and everything is running off of the grid. Even if we unplug the inverter, we're completely on the grid now. So we are feeding into the battery. Now, what happens when you drive away, you unplug, these numbers are going to reverse. So instead of putting power into the battery, we're going to immediately draw power out of the battery. When you unplug from the grid in our setup here, it's going to immediately switch back to the inverter. So we'll go ahead and turn the inverter on. And going to kill the power grid. Our light should blink. So the light blinked for just a split second, and that was the switch inside here, switching back to the inverter as the power source. And you can see we're at negative 23 watts now. So just like a bank account, a negative number is a withdrawal. So we are withdrawing 23 watts from the battery now. We were putting in a positive wattage from the charger, and now we're making a withdrawal. Just instantaneously, the numbers will reverse on the battery monitor. So that is the gist of the transfer switch and how to add shore power to an existing system where maybe you have a solar charger and you have a inverter that you've already purchased and you want to add in the transfer switch. This also works if you have a generator. I had a student contact me. He had a Winnebago Travato, I believe it is, and he has a generator in there and he wants to integrate that with some new electronics that he wants to put in, and a transfer switch is a good way to integrate that generator with other power sources such as an inverter or the power grid. So I hope that was helpful for you. I want to say one last thing. So you may be wondering, this is an inverter charger, and this does multiple jobs that we have here. So there is, it's kind of heavy, but there's a transfer switch, there's a charger, and there's an inverter. So transfer switch, inverter, and charger, they're all in this case. And I have to say they work seamlessly together, and the specs on the charger, inverter, and transfer switch in here, they all outperform what I have here. So it's a larger capacity transfer switch. It's 50 amp instead of 30. The inverter is 1600 watts instead of, I think I have 300 watts there. And this is a 30 amp charger. It's got an 80 amp charger. And this is a small inverter charger. This is not very large. There are some larger models. Go ahead and set that back there. But I just want to point that out. You may want to go with an inverter charger if you're doing a brand new power system. So instead of getting the separate components and wiring them together, you would want to get the inverter charger. It's going to give you more performance in a pretty compact package. And the other thing it does is it turns your inverter off. So when you plug into the power grid, it's kind of an overlooked detail, but you have to manually go and turn your inverter off. And you know, you may have a remote switch so you can just turn it off in your control panel. I have seen people that leave their inverter on no matter if they're plugged on to the power grid or not. They just leave the inverter on all the time. But with the inverter charger, it'll actually, you plug into the power grid, it says, all right, we're on the grid, and it turns that inverter off, and it turns the battery charger on simultaneously, and that's all automated. So just something to note. If you're wondering what the difference is between the transfer switch and all this and an inverter charger, they're very related, and you'll just want to use them based on your specific scenario. So I hope that was helpful. Thanks for watching. Again, if you want additional help with your overall power system, you got to grab a copy of the Ultimate Van Power Cheat Sheet. Just click that link below or go to rosslukman.com/vanpower. Thanks for watching, and I'll see you in the next video.